In the name of God, in this session we are talking about uh, ADH or antidiuretic hormone and oxytocin, the two main hormones of the posterior hypophysis. In the first slide, you see that the sum of the neurons located in two different nucleus in the hypothalamus, the supraoptic nucleus and paraventricular nucleus, are secreting these two hormones, and after transferring through the axon by combining to neurophysin, which is the name of the carrier, they will release in the posterior part of the hypophysis. But there is a mistake in this slide. The paraventricular nucleus is mainly responsible for producing oxytocin, and the supraoptic nucleus is mostly important for producing ADH. So it must be corrected in this slide. Neurophysin 1 is mostly important for carrying oxytocin, and neurophysin 2 is mostly important for carrying vasopressin. The physiological role for neurophysins is not elucidated, it's not clear, but after releasing in the blood circulation, because of the pH of the blood circulation, the neurophysins will be detached from the hormones. We can see that both oxytocin and ADH, they are composed of 9 amino acids, very similar to each other, but their functional and physiological role in the body is different. ADH, the other name of ADH is vasopressin, but they are not different hormone. Both of them are similar hormone. ADH is similar to vasopressin, but when ADH is secreted in the level of the physiological, and its main role is the reserve of the fluid, and especially the water, and will not let it go through the urination. So the absorption of the water from urinary duct is the main responsibility of ADH. But when the blood pressure is dropping, or sometimes because of the very low volume of the blood, the ADH is secreted in the very high level. In this level that we call it the pharmacological level, the name will be replaced to vasopressin. Vaso means vessels, and the press means pressure. Because of the pressure to the vessel of the body, the blood pressure will be increased. So they are not different hormone. They are similar hormone to ADH. But here we see that in the next we see that vasopressin or ADH have different receptors in different organs. When the level is in the physiological in the physiological basis, we call it ADH, and it go to the renal uh, renal duct, and it will cause by action to the V2 receptors to reabsorb the renal fluid from the urination. So it will increase the blood volume, and ultimately the arterial pressure will be increased. But when it's secreting by higher level, the name will be replaced to vasopressin. It will go to the smooth muscle of the vessels, and by acting through the V1 receptors, it will compress the vessels, and the result will be increasing the arterial pressure. In this slide, we are going to the effect of the ADH on renal tubules. The receptor for ADH is located in the distal part of the nephron. It's especially in the collecting ducts, either in the cortex or medullary part of the collecting duct. But ADH will permit reabsorption of the water from urination to the blood vessel. Here we are just magnifying one cell from the collecting duct of the nephrons. We see that the ADH is coming through the plasma because it's a hormone secreted by the posterior part of the hypophysis, and its receptor is located in the basal lateral part of the collecting duct cells. This is a G protein receptor, and after activation, it will cause adenyl cyclase, and ultimately it will prepare and create protein kinase A. What is the role of kinases? It can give or phosphorylate some proteins. But which proteins? For absorption of the water, we have some channels specifically for water in the other or luminal part of these cells. We have different parts. We call these channels aquaporine. It means so aqua means water and porine means channels. We have different parts of the aquaporins. The most important aquaporins are aquaporin 2, which is normally is it's inactivated and it's located in its inactive form in the cytosol. After activation of protein kinase A by ADH, they will be phosphorylated. Aquaporin 2 will be phosphorylated by protein kinase A, and after phosphorylation, they will be active and inserting to the luminal part of these cells. So letting absorption of the water. We have different also aquaporin number 3 in the other part, but it's not under the control of ADH. Um, in 2003, the Nobel Prize in the chemistry was awarded to a biochemist because of the discovery of aquaporin. As I was telling you before, we have different of aquaporins. Some of them are also involved in the pathology of some diseases, especially the Alzheimer diseases. For example, aquaporin number 4 is important for the clearance of plaque of amyloid plaque in the brain. So when we have the lack of the aquaporin 4, it's very probable that we get Alzheimer. But how the body understands that the ADH must be secreted by supraoptic nucleus in the hypophysis, in the hypothalamus. Um, the most important stimulator for ADH secretion is the osmolarity of the body. Osmolarity means the number of the osmol in the 1 liter of the body. The normal osmolarity of the body is 300 milliosmol per liter. If this osmolarity will be go up or down, all the cells will be disturbed. For example, if we in the condition of hyperosmolarity, what will happen to the cell, specifically the nervous system? They will lose their water, so they will be shrinkage. On the other hand, in the hyposmolarity, the cells, specifically the nervous system, they will absorb water and they will swell. So in both conditions, because of the disturbance in the osmolarity, the cells will be die. But for prevention of this condition, specifically in the hyperosmolarity condition, the body reacts by creating and secreting ADH. And ADH, by absorbing water from the urinary duct, the water will come back to the body and the osmolarity will be corrected. But how it will can happen? How supraoptic nucleus understand that the osmolarity of the body is changing. There are some osmoreceptors. They must be located in some parts of the central nervous system. Some persons say that they are located in supraoptic nucleus, but the most probable part is some organovasculasm. Organovasculasm is close to the third ventricle, and this is very sensitive to the osmolarity of the atmosphere around. In the condition of high osmolarity, the cells in the organovasculasm will they will shrinkage and because they lose their water, and the end of the nervous system, which is located in organovascularism and going to the supraoptic nucleus, they will be stimulated. And after that, the supraoptic nucleus secretes ADH. And ADH will let the water absorb from urine to the going back to the body, and the osmolarity will be corrected. So we have some stimulation for ADH or vasopressin and some inhibitors for this hormone. There are three most important stimulators of ADH. The first one I was talking about, increased osmolarity. In this condition, ADH is secreted in the physiological level by the name of antidiuretic hormone. It's going to the urination duct, and by acting through the V2 receptors, it will reabsorb water. And sometimes, in the condition of decreased blood volume or decreased blood pressure, the level of the secretion of ADH will be increased. So the ADH will be secreted in the name on the name of vasopressin, and by going, it will not only going to the urination and by absorbing water, it will try to gain some volume and blood volume, but also will go by the name of vasopressin to the blood vessels, and through the activation of V1 receptors, what will happen? It will compress the vessels, and the blood pressure and the blood volume will be increased. The other important stimulator is angiotensin 2. I will tell you how it's created in the body. Normally, in the condition of low blood pressure or low blood volume, this is the reaction of kidney which help to create angiotensin 2. Angiotensin 2 is also a compressor of blood vessel like vasopressin, and it will increase the blood pressure. Pain, nausea, and stress also increase or stimulate the secretion of ADH. And during aging, nicotine is, usage and opioid. But ethanol, cortisol, thyroid hormones, and also I will talking about ANP, which is a physiological inhibitor of ADH. Um, after two slides, we can see how the angiotensin is producing in the blood circulation. Normally, there is a big protein angiotensinogen, which is secreted by the liver. It is normally in the blood circulation. During the low blood volume or low blood pressure, the reaction of the juxtaglomerular cells in the kidney is to produce renin. Renin will convert angiotensinogen to the angiotensin 1. After passing through some capillaries have some enzyme. We call it ACE or angiotensin converting enzyme. ACE can convert angiotensin 1 to angiotensin 2, and angiotensin 2 is a very potent stimulator of ADH and also a stimulator of aldosterone. These three hormones, aldosterone, ADH or vasopressin, and angiotensin 2, can save the life of a person during hemorrhages and when the blood pressure is very low. But sometimes not only the high blood pressure or high blood volume can react the body by producing angiotensin, by producing vasopressin, and by producing aldosterone. In the contrast, there must be an opposite hormone in the level of very high blood pressure or very high blood volume. The name of this hormone is ANP or arterial natriuretic peptide. This is a peptide which is produced by the cells of the atrium in the heart. After stretching by high blood pressure or by high blood volume, these cells will producing ANP. By letting more defecation or more urination of sodium and water in the urine, the blood pressure and the blood volume return to the normal level. So ANP is the physiological antagonist of ADH. Desmopressin is the name of the analog of ADH. Sometimes it's used during diabetes insipida. This diabetes it's not because of the high blood sugar or high sugar in the urination. This is because of the lack of ADH. So a lot of urination and a lot of thirst will be happen like diabetes in these persons. But after using desmopressin, everything will be okay. Sometimes the problem is not by secretion of the ADH. This is we have the nephrogenic in diabetes. In this diabetes, the responsibility is because of the lack of receptor or the receptor is not well functioning in the kidney. So after in this person, desmopressin is not working because we have enough ADH, but ADH is not functioning because of the some mutation in the receptors in the kidney. And the other hormone of the posterior hypophysis is oxytocin. Oxytocin is during lactation, will let the milk go out, and also it's necessary for parturition after pregnancy when the baby wants to go outside of the uterus, and yeah, oxytocin, the receptor of oxytocin is present all over the brain. This is a very important hormone. We call it the love hormone. During orgasm or some sexual function, the level of oxytocin will go up. And because of that, the satisfaction of orgasm is because of oxytocin. When the oxytocin is high in the brain of some persons, these persons are more optimistic. They are not negative persons. They are very optimistic. They are not depressed. It's the antidepressant hormone in the brain, and it's caused the satisfaction of the person in the life. So, and also the receptor of oxytocin is present in the hippocampus, the center for learning and memory, and it's very important for learning and memory. Okay, enough for uh, uh, for posterior hypophysis hormones. And if you have any questions, please write it, and I will ask them. And I will be very glad to to answer your questions. Okay, thank you for hearing my voice. Bye bye.